Great, so thank you very much for coming here. So my name is Muir Freer, I'm a researcher at the Tyndall Centre, postdoc now, so we'll be talking about carbon capture and storage and GIS. Just for a sort of getting the lay of the land, who knows what carbon capture is, but they're quite familiar with it. Okay, so we don't have to go into too much of detail what it is. But there is one slide, so basically what is carbon capture and storage? So it is taking a big emitter, that's big, could be a range of sectors, it's not all just oil and gas, huge range of sectors where you're then integrating carbon capture technology to where the emissions that you would be emitting are captured, transported and stored geologically underground. It's a really particular set of geology. You can't put CO2 into just any rock. And when you talk about carbon capture, you talk about the clusters in the UK. So there are rapidly developing little regions around the UK where lots of big emitters are all together, they have the infrastructure together. They are now sharing infrastructure to then have that infrastructure to store CO2 offshore. The main ones, they're called Track 1 facilities, I'll come on the site, are the northwest near us. We have the Humber cluster, which is partnering with Teesside for Track 1, but then Track 2, which is one rung down, where they get a little bit less funding for them, is the sort of Viking cluster, which is brand new, and then the Scottish cluster. All other clusters are popping up around the UK, have not actually got to that level of government support, so it's still developing. This is a brand new one that's just popped up a month ago. That one came up last week, so it's a really rapidly developing field. A lot of people say that there's been no progress in carbon capture and storage, but as we're showing today, I'm going to be showing a digital twin model, and it's absolute pain to keep up with the developments in carbon capture and storage, because you want the most up-to-date sort of snapshot of what it's like. It just takes ages. Eventually, the government's just put out reports for setting up, they've invested 20 billion into setting up a carbon market by 2035 for the UK to force CCS to integrate into. The business models are getting developed for certain types of carbon capture, so these facilities are rapidly developing. Clusters are sequencing, they get the funding, they're expanding. The HyNet one has just moved into Peak District, it's moved into Barrow. It's really rapidly expanding. So it's a really exciting time to do GIS modeling on carbon capture and storage. Next. Ooh, no, there we go. So these are just the 3 carbon capture projects that I've been doing this year. So the first one was with a UK CCS RC. So the problem with the cement sector with carbon capture is really applicable to put the technology onto it, but they're nowhere near the clusters, and you're like, how do I connect to these facilities? This is modeling, it's called the Peak cluster, it was on the previous one, but these 6 cement facilities, they want to connect to offshore geological storage sites. We did the modeling to say, how do you connect that? What transport modes are you taking? What happens if the storage flexibility means? Because flexibility is key for carbon capture and storage. Your facilities here, they want to store in there. What happens if that goes offline? How much does your network kind of have to pivot around that? How do you build in that sort of flexibility into your networks? That was that project, focused on the cement sector. The one that's just finished was IDRIC. So we evaluated bioenergy with carbon capture and storage. These are really critical technologies for the UK to meet net zero. And people are looking at putting them in the clusters. So what we did was we put in 5 supply chains, all co-located in the same location, and we wanted to evaluate whether or not they kind of synergize together, or did they compete against each other to steal resources, do they kind of crabs in a bucket to kind of slow yourself down. We did that modelling, and that's just one from there, that's dedicated to biomass. We did lots of remote sensing, building up networks and repositories of biomass data at high spatial resolution to build supply chains at certain scales to say how do they coexist together. And when they have dedicated biomass types, they're okay, it's not stealing your biomass. But when you have a competitive one, as lots of companies in the area have all independently said, we want waste wood, they've not told each other, they're trying to set up their supply chains and they're just going to eat into each other. You rapidly reduce how much X you can do in an area, which again rapidly changes whether you are centralised to clusters or you're somewhere else in the UK. The project that started this week is the UK Research England. We're looking at combining those 2 methodologies together for the entirety of the UK to see how do you connect your carbon capture to your storage. What are the policy implications, what are the social implications, which we'll get to later, and what are the network flexibilities, because you'll never get the storage sites that you really want. There will always be need for flexibility options. You can't build up all this infrastructure in the UK is built in that way. If you can't have it, can you go that way? Because a lot of the storage is either here, 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 or here. It's limited to certain locations. You need to know if you set up these great big facilities, you're banking for meeting net zero, what happens if something goes wrong? You're kind of building these sort of evaluation scenarios. As well as this one, we can run simulations as well and say, what happens if a heat wave comes in, knocks out 50% of your biomass supply? How does that affect how these sort of supply chains work together? A little back into the cement one, we found it was really helpful when engaging with the industry to have these sort of dashboard diagrams that say at a glance, this is what it's looking like for your integration. So each of these circles are cement facilities which we've modelled to show this is how you connect to your storage for your first choice. A lot of these facilities go that way. South Wales have to get ships. They go all the way around, integrate into the northwest cluster, and then store geologically. So a lot of these clusters cannot exist by themselves. A lot of them will have to pair up another one, and you have to figure out where they are. And eventually the network will build and build and build. More and more storage will come online, opening up new areas. Normally when we did this analysis, that cluster didn't exist yet. As soon as we sent the paper to the journal, they announced the cluster, which really annoyed me. But it's always rapidly developing. You get these sort of breakdowns of what's the cost of in carbon for the integration, what's the cost in physical money, what's the cost in distance, what's your storage type. You can really get a laydown for these facility operators to get a sort of, here's a quick look at what you can do, what you like, what you don't like. Here are the issues that are coming up for you. So just to explain the sort of model that I created in the PhD, it's called the Carbon Navigation System. So you can take any sort of supply chain in the UK and build your supply chains to whatever sort of capacity you want it to be. It uses a lot of network analysis in GIS, but it can be applied to any supply chain. So here's a little rushed sort of diagram to explain how this sort of modelling works. So this is just the CO2 limb. So the model is built up with these limbs here. So each one is a representative network that's tailor-made to handle what you're moving around. So that biomass limb is tailor-made for everything you need to move biomass around the UK. The hydrogen one is for everything you need to know about moving hydrogen around, the CO2 for CO2, and the energy link for electricity, biogas, whatever you're moving around. It's all tailored to transport types, tailored to high spatial resolution. There's right down to the polylines, quite a couple of meters resolution. Pick anywhere, simulate it. You can change the cost metrics, so you can say, I want to know how much carbon the supply chains are producing, or you can say how much money it's going to cost me, or how much distance. You can even put time in it. You can really change it around to customize it to what you need. So taking this one for example, it's split up, each network split up into different transport types. The objective is to go from here to there, and the network will swap between automatically these different stacked poly lines to minimize what your cost was. So if you're minimizing CO2 emissions, it will take a truck for a bit, go to a port in the model, it will swap over to that, go for a ship, go back down to the HDBs, move over to your cluster, back up and to storage. It will automatically do that for any sort of location in the UK. If you want to know more about it, we've got the paper there from 2022 and a post research blog where we find a bit more about the sort of model. I hope I don't this. Where is Yorkshire? It's a really interesting thing for GIS. Every single time I've engaged in industry, I accidentally insult someone's location. I say, Plymouth is really poor for municipal solid waste production. There will be someone from Plymouth who takes offence to that, so you have to be really careful when you're talking about regions around the UK. But you can see here, with these two regions, both are technically Yorkshire. Yorkshire is like such a chaotic place to know where the actual lines are. But the most important thing for me is that there's two clusters right here, right where there's a difference in what is classified as Yorkshire. It's a really interesting space. As well as the sort of coexistence of lots of different county systems. A lot of them kind of just put Scotland into one big group. A lot of them just put Wales into one big group. But since we have a South Wales cluster, you really want to differentiate that from a North Wales cluster. There's like completely different efficiencies there. You can't just say Wales 1, Scotland 1, then a huge smattering of regions for England. So it's really quite important to get that into people. So especially when we're engaging with industry, a lot of them want to know, I want to set up a supply chain in this region compared to this region. I want to know that Humber is better than East Midlands. I want to know which region to go into. And depending on where you draw that line, these regions around here kind of bring up the average for that area. So it's really important to say where these values are. You have to be really transparent with that. It's bringing this into this sort of carbon gerrymandering that can happen when you're talking to industry. It's really important to say the right name for the right place, like I accidentally insulted people. But especially for these regions, Humber and Humberside, a lot of locals will find great offence to their sort of heritage for the area if they call it Humberside. There's this really famous graffiti of the area when they were changing the sort of county region where people graffiti said, we're not Humberside, we're Humber. And a lot of the government reports to this day are still calling them Humberside. So if you're trying to engage with these people in these locations, you're already off on a bad foot just by using the wrong name for them. I've mentioned already, you have two clusters in that region that are really close together. So you can see Drax is just the example quick for the Humber cluster. That's just there. You have two different companies working in the same space. Ideally, you have altimeters in there, and they want to entice them to join their network. So there's a huge sense of competition between that. So just knowing where those sort of lines are is a really important factor in there. So what we do in the model is a macro energy systems analysis. So instead of just modeling one location, how it connects throughout the supply chain, you repeat it over and over and over again for a huge variety of locations across the UK to create a heat map. It's a sort of carbon performance heat map. So instantly, like, this region is green, it's good, this region is red, it's bad. You're better off setting that particular supply chain up in this area of the UK. You're able to do that quite well. But then it goes back to how are you chopping up when you have that map. How does the Humber region, what's that area, what is the South Wales region? You have to really be transparent to that. And the really sort of important thing around GIS modelling is not to get kind of bogged down into it. There's lots of other sectors around it. First 2 years of my PhD, I was just GIS mode, where I was forgetting to incorporate the sort of non-technical, sort of social, financial, regulatory systems that need to be incorporated into the model. Then you really have to be careful of that, and I'm learning a bit more every day. So just going into the conclusions, there's a huge demand for spatial carbon capture modelling. It used to be me and 4 other people. Now there's huge companies all creating these spatial models, especially for the UK, France, India's got one now, America's got one, Canada. A lot of them are trying to buddy up together so you can have systems of, well, mine's just the UK, but a lot of other systems are going to try and pair up countries together to see how they integrate together, how do you connect, how do you send your CO2 to another country, because not every country has geological storage space. So they're going to have to buddy up with another country to store their CO2. And that's a really exciting space in the area to show how do these countries connect up, who's the emitter, who's the storer, if you're doing X, who's the supplier of your biomass, you send over, who gets credit. And as well as the sort of clusters around the UK are rapidly expanding. It's a really exciting time, and a lot of other countries are copying the sort of UK business model and creating their clusters. I think a really interesting space that's going to come up is the sort of interplay between clusters. Because right now they don't talk to each other. So you have the Northwest cluster and a Humber cluster. They're kind of competing against each other. They're having breakthroughs. How do they kind of steal from each other? How do they cooperate? I think that's a really interesting space to go into. But then also the emphasis on pipeline versus non-pipeline transportation. If you are in the sort of Northwest cluster, it's easy for you to build a pipeline into it, store offshore. But if you're in South Wales, you're nowhere near that. And all the legislation, all the policy is built up around these clusters, which are centralised. They have this CO2 storage. These dispersed emitters are going to be left behind. So it's really important to show it's the UK as a whole, not just these one little clusters. Thank you very much.
We've got a few minutes for questions again, if anyone's got any questions they'd like asking.
So this clearly is quite linked into the actual development of it. What's the relationship there between the kind of academic endeavour and the, is it a commercial thing or is it like a policy? How does that work?
It's a purely academic. We do engage a lot with industry to make sure that the model is correct.
Okay.
So we've got really close connections with the HyNet, it's the Northwest clusters. We're able to talk to them wherever we want. They're quite secretive. As we were doing this project, they hadn't announced that they were building a pipeline here. So in our initial analysis, our model showed that these facilities should go to another cluster. And as soon as we showed that to that company, they kind of freaked out a little bit. If we were trying to get funding for this pipeline to connect in here, because it makes sense for us business-wise, And if your research shows, no, it should go to be our competitors, that's a huge sort of contrast of ideas there. They really wanted to show there. But the only reason why we showed go to the other cluster is that we didn't know they had the capacity to build that pipeline there. They've been so secretive about it. So it was just because of those connections, those sort of checkups that they have with them, just make sure that everything's kind of on top is there. But I regularly following like announcements around carbon capture storage around the UK. It is a pain. It's like 6 a day now. But it's rapidly building out, and these sort of clusters are looking at, and it's only capable because we're checking in the industry to make sure it is correct what they're doing.
Cool.
It's purely, there's no business aspect to it.
Right, yeah. So you haven't provided these as services to these?
No, it's, but I'm hogging it to myself.
So this, I think we're talking mostly about sort of light point sources, aren't we, like cement manufacturers? Has there anything for this on direct air capture as well? Because then presumably it could be way diffuse and not really complicated.
That is a really interesting space here. So, so the way that building model is that it's fully customizable. You don't have to use every single limb in every single aspect. So with DAX, you just be using the CO2 limb. Since with DAX, you want to be as close as possible to your storage to minimize your transportation costs. So what the model suggests is that if you're doing DAX, you want to do it on the gas landings. Gas landings in each of the clusters, you want to be as close as possible to the point at which you're transitioning from onshore to offshore. Those are the sort of prime locations that you're having. But there's lots of research around sort of dispersed sites because it's getting busy, these clusters. If you're having more and more projects kind of build up there, there's only so many plots of land. You need to prioritize which one's going in there. So for that, you would want to put it in the gas landings. Or if you can't get that, there are certain dispersed sites around there where you can tap into. Some small DACs can be put on top of buildings. So you can get these sort of, they're calling them super places, but I don't like that term. Where you have a carbon capture facility with DACs on top, two completely different systems sharing that infrastructure to store. That's the potential, but ideally you want to be as close as possible to that gas landing in the Northwest Cluster or Scotland or South Wales. It's just as close as possible. Ports and rails will also be very powerful locations as these spots kind of fill up. So you want to be near these sort of low carbon transportation switching locations where it's easy for you to go, I'm next to a rail terminal for low carbon, I can hop onto it and connect to a cluster. Because if you're not near that, you're going to do very carbon intensive trucks to connect in, staying over. And for a lot of these projects, it's all about the net carbon balance. It's where the emissions that you produce in your supply chain are kind of offset versus the sort of emissions that you store underground. And the more transport you have to do, the more you're eating into that net negative carbon balance. So your projects get less sustainable, and the carbon credits that you could claim get less and less. Your company makes less money. So it's really important to put your facilities in the right place, and then also take into consideration sort of social aspects of that. You're not just going back to location to do it, you have to integrate it into the whole system.
Any more questions? Fabulous. Thanks very much, Neil.